Alrighty, all. Today we're taking a look at another one of our lectures, and this one's about the seasons and why they change, right? So we know that it can't be, well, we talked about that it can't be because of the distance to the sun, right? Us in the northern hemisphere, we know July is summer, January is winter, so we want July to be warmer and January to be colder. Right? If we're closer to the sun, right, 147 million as opposed to 152 million kilometers, if we're closer to the sun in January and further away in July, being closer to the sun isn't what's going to cause it to be warmer, right? This also is because, right, the Earth is always, the northern and the southern hemisphere of the Earth are going to be effectively the same distance to the sun. So if in July we're further away, and if that made it colder, then that would work for the southern hemisphere. And January we're closer, and that would make it summer for the southern hemisphere. But we know that when it's winter in the northern hemisphere, it's summer in the southern. So if it was just purely based on distance from the sun, the northern and southern hemispheres should be the same. But they're not. So, no, it's not based on how close we are to the sun. So, now we get to our diagrams here, right? First thing we're going to be taking a look at is, we're looking at our person in Syracuse and stuff. We want to start by shading in the side of the Earth that's in darkness, right? So here's our line marking, and there's our nighttime. All right, sun's coming in this side, it's only going to be lighting up this half of the Earth. So if I do the same thing down here, we have that side's in darkness, right? And then we wanted to look at, I'm just going to draw a person on all of my different places, all right, because we're just going to look at all of them. Okay. So we have a bunch of different people all around the Earth. We need to figure out how much sunlight they get in June and in December, right? So if I'm drawing the person's path, right, some of them already have them drawn for me. I drew them intentionally on those lines. But here's our person in Syracuse. I'm going to draw their path going around the Earth. It's going to look something kind of like this. It'll be a straight line, right? Because we're looping around. Right, here's our axis of rotation. The equator's just kind of going around like this. It's going to be rotating around that same line with different bands around our Earth, right? So we're just going to be going around the Earth like that. So in June, we can see that if this line represents, well, half of our day, right, because we go in front of the Earth and then behind it, this line is half of our day. We can assume the line looks the same on the other side of the Earth. So I can say that this part of my line is in nighttime and the rest is in daytime. If I were to guess, I would say this is 1/3 of the day. That means that a person in Syracuse in June would have about 16 hours of daylight and 8 hours of nighttime. Okay. And then a person on the Tropic of Cancer maybe would be like, I don't know if that's like 2/5. I don't know. 2/5. Oh, I said 2/5 would be nighttime, right? It's a rough estimation, right? But you're taking 24 hours in a day. Sorry, my brain's still waking up, right? But if we take whatever estimated portion of our line is in nighttime or daytime, multiply by the number of hours, so this would be 3/5 times 24. That is our amount of sunlight, right? We can see the equator is kind of split down the middle, so it's going to be 12 and 12. Our Antarctic Circle is going to be entirely in nighttime in June. The Arctic Circle is entirely in daytime. We can look at the same thing down here. Now in December, the Arctic Circle is entirely in the nighttime. Antarctic is entirely in daytime. And, all right, here's my Syracuse person. That, now it's kind of flipped, right? If this was a third up here, now we have that same third, but now it's 1/3 in daylight and 2/3 in nighttime. So up here we had 16 hours during the day, 8 hours at night, and now we have 16 hours at night and 8 hours during the day. And it's the same thing for each, right? We have this little bit on the Tropic of Cancer. It's the same as this little bit, but it flip-flops, right? So now we have to figure out, now we're looking at how we see the sun in each of these different locations. All right, so if I get rid of all this mess, oh. No, I erased my shading. That's fine. Close enough. I got most of it. All right, and I want, sure, I'll keep this line here, right? I want to think about how I'm seeing the sun each of these times. So I'm going to draw a person in the sun. All right. So our trick with this one, all right, is to mark our horizon first. And it says in the instructions to do that, draw some arrows for your horizon and for looking straight up. Right, so my horizon is going to be tangent to the circle, this person, because when I'm standing on the Earth, there's a reason for the conspiracy theory. It looks flat, right? I'm not seeing this rounded shape of the Earth. I'm seeing it as flat. So all I'm doing when I draw my horizon is I'm taking that perspective of saying this person would see it as flat, looking like this, right? So they're standing upright on what would be their flat ground, and I just extend it so it's easier to see what's going on, right? Then if I want to find out how they see the sun, right, I know the sun's coming in these horizontal lines, so I'm just going to grab a horizontal line. It'll snap into place for me, right? And there's a horizontal line showing where the sun's coming in. I just plonk that somewhere on my horizon, right? This is going to be my how high in the sky is it, right? This angle here. Because if this person was looking straight out the horizon and then a little bit up, that would be the direction that the sun is coming in, right? So person in Syracuse in December, right, we said this side, we're going to be like noon on this side and midnight on this side because they're either as close as they get to the sun or as far away, so the sun is the highest in the sky for each of these people where I drew them. So it's pretty low at its highest point in the sky. Okay, and I do the same thing for each one. Here's my extended horizon. The sun comes in a horizontal line. That's not very horizontal, but it will be. There's my horizontal line, and there. All right, now this is kind of like maybe in the middle of the sky, kind of medium. All right, this person, all right, I have my horizon like this. I mean, my horizon's kind of already a horizontal line. So when the sun comes in for this guy, it's going to pretty much be at or below the horizon. Right? Because we said the Arctic Circle isn't going to see any of the sun because it's kind of entirely in this darkness, this nighttime. That's really my thing. I'm going to take my tangent line, extend it so I can see more clearly where the horizon is, and I bring my sunlight in, and this is pretty high in the sky, all right? So I've been just saying high or low, but we can also describe it north and south, all right? If I'm at the North Pole, everywhere is going to be south. So south is going like that. South is going down around the globe. Kind of like that. I'm not going to draw it on the side with the people because that's getting a little messy over there, right? And then north, same thing, right? I'm going around like this. For any person standing on Earth kind of like this, north would be up like that, south would be going down this way. Right, so this would be low in the southern sky. This would be kind of in the middle in the southern sky, high in the southern sky. I haven't done this one yet. All right, here's our horizon. Here's the sun coming in. If I were to do this, I didn't really draw it super well, but that's pretty close to a 90-degree angle. That means it's going to be directly overhead. All right, here again, we have our horizon. We have the sun coming in. There's my horizontal, locks in for me. All right, that'll be probably pretty medium in the middle of, and remember this way, this is the northern sky. So in the middle of the northern sky, kind of like that. All right, so that's a lot of what we talked about. This was where things are in the sky, and how much daylight we're getting in each, for each solstice, and also being able to place where in the sky it is. All right, so if I were to do the same thing over here, I draw my people. You need to draw the people, right? All I need is just a pretend extended horizon, a tangent line to my circle. It's a pretty bad tangent line. All right. Then when the sun comes in horizontally, I can see that's pretty much on the horizon. This one, if I draw my tangent line, I have the sun coming in horizontally. There it is. That's kind of low in the sky. That's low in the northern sky. Draw my tangent line, draw my horizon. I'm not very good at drawing tangent lines, but it's a rough approximation, so it's okay. My horizontal line for the sun. So it's kind of high, again, in the northern sky, because when I draw this little angle, right, if I wanted to, I looked at this one, right, I could draw my tangent line, draw my horizontal line. That was a very squiggly horizontal line. Where is it? There she is, right? I could look at this angle, right? But that's bigger than 90 degrees, right? My zenith is somewhere like that. So this, if I was looking at it in terms of the northern sky here, I would have to go past the zenith and into the southern sky. That's why we're really looking at this smaller angle and saying the sun is in the southern sky here, and it's going to be pretty high up. Because remember, I'm looking towards this horizon, I'm looking out this way, and then I'm looking up higher, right? So I look south and then up to see the sky, or to see the sun in the sky. All right, and here's my horizontal line for this one. Again, this one's kind of close to 90 degrees, and I said 90 degrees. That's directly overhead. That's at our zenith. And this one, our horizon there, horizontal line. That's pretty low in the sky, low to medium maybe. My tangent lines are a little off. As long as you have like a rough approximation of, and a justification of why you're thinking the way you are, that should be pretty good as to what's going on, right? All right. I know this is a little bit of a quicker one. Let me know if you have any more questions about this or anything else that you want me to try to explain. And I'll do my best to try to explain it, because I guess Sydney explains stuff.